Among the properties of logarithm, let's look at the following property. Log base A of a product x times y. So x and y here are any two values. So log base A, where A is a base being positive and other than 1. So log base A of the product x times A will equal value with log base A. Notice the same base with that beginning log problem. Log base A of x plus log base A of y. So this property is a property that is indeed proven. But in this quick lesson here, allow me to skip the proof, the formal explanation of why it was true. But we just generally understand this as anytime taking logarithm, regardless of whichever base that is, taking logarithm of a product will equal to taking two separate logs. One on the x factor, and one is the logarithm on the y factor. And then add the two logarithms together. Notice how the two logs here are of the same base with the beginning log. So this property goes from a product to a sum. So a lot of time this property here is regarded as the product to sum. A product to sum rule, or a product to sum formula, a product to sum property. There are many ways you can say that. But we call that product to sum. No, alternatively, this is only one way of writing the product to sum rule. And according to the way how it say product to sum. So reading the property here from the left to the right, we can see that it goes from a product on the left, taking logarithm of a product, equals to, or can be converted to, the logarithm of the x as one factor in the product, plus the logarithm base A of y, the other factor in the product. But now with this equality between the two sides, we are seeing this as a product to sum. We can also think the other way around. There will be times where, so it's the same property, but we can think of this equality as log base A of x, because there will be times where we are computing log base A of a single x value, and then we need to add with log base A, same log, of another value y. And we can sometimes conveniently re-express this or recalculate all this as log base A of the product x times y. So this is an alternative version of the same property, the exact same property, this exact same rule. And so in that way, you may hear people here and there refer to this rule. In this way of writing it, we can refer to this as the sum to product. It's the rule to go from a sum to a product when you're working with logarithm. Sum to product rule. And it's a property that's well proven. But again, just as I mentioned earlier, I will skip the formal proof, the formal explanation of why this rule is true, this property is true. And we're just going to get to the practicality, the practical usefulness of this. So now to see how useful this property we have learned is. This product to sum or sum to product, these two are essentially the exact same rule again. So we can use immediately in the following computation problem. So in my quick example here, let's evaluate. So how about as problem A here in this current example. Log base 10 of 2.5 plus log base 10 of 4. And so there will be times we run into a computation problem as following: log base 10 of 2.5 plus log base 10 of 4. More naturally, a lot of people will think of the following solution. We go log base 10 of 2.5 on the calculator. And yes, once we're done with that, we're going to add with log base 10 of 4. And the answer will come out 1. That's one solution. For people who have calculator a lot more basic than the one I've just shown on the screen earlier, then the order of the work here, the order of the operations here is that we have to take the logarithm base 10, log base 10 of 2.5, and take the logarithm base 10 of 4. Those two will turn into very ugly looking decimals. For example, log base 10 of 2.5, the real answer to that is a very ugly looking decimal. And we're going to add that answer to, so I'm working in a way of how, I'm working in a way that anyone viewing the lesson here is having a very basic calculator, even more, a lot more basic than the one I'm using here. So the answer from log base 10 of 2.5, I'm going to add with the answer of log of 4. Okay. And then we get this answer. But now, in the worst case where we don't even have any calculator, then, and you can already see that even if with the calculator, it's not going so well that we have to type in so much, even if the some advanced calculator already. So utilizing this rule over here, now we don't even need to use a calculator. So my point now is that this computation problem can be done without using a calculator. Using the understanding of our product to sum rule, or using our understanding about the sum to product rule, I see that I can bring this sum, because it's same log, same base of the log, same base of the log. I can bring these two into one logarithm, log base 10 again, of the product of these two numbers. So these two numbers will be multiplied together in my logarithm. So 2.5 times 4 will equal 10. 2.5 times 4. And that is the same as log base 10 of 10. And the answer will come out as easy as 1. As another computation problem, we can utilize log base 3 of 4 plus log base 3 of 2.25. And now with a logarithm computation problems like this, where it's log base 3 other than the log base 10 that's commonly given in a lot of calculators, and the log base e, then it's very inconvenient to punch each one of these into a calculator and just to add the two answers here. So the better solution for us here is without the calculator. So we know at this point that a sum of two logarithms of same base can be rewritten as one logarithm of the product of these two numbers. And so we can utilize the exact same property here in this problem to make our computation going a lot faster. So now I can rewrite this as log base 3 of, now 4 times 2.25, and 4 times 2.25 equals 9. So this is the same as log base 3 of 9. The answer will come out as easily as 2. And I had spent some time explaining the steps. That's why it takes a little bit of time. But when we're actually doing this, it's going to be a lot faster. And so at this point, I really would like to emphasize that the two formulas here are essentially one property. We can go from a product to a sum of two logs, or from a sum of two logs into a product. I mean a log of a product. Or we can go from a log of a product to a sum of two logs. And so the earlier example I showed emphasized on how we can use the same property as a sum to product rule. But then, allow me to show another example where we can expand a logarithm expression. So the simple instruction of this example is just to expand, and you will understand exactly what it means by expand once I finish writing down the actual problem. So now, instead of having an actual logarithm computation problem, let's say we're looking at a logarithm expression. So log of a product 10x. And just now I said it, log, whichever base that is, log of a product 10x. I see this as a product inside a logarithm because it means 10 times x. And so now, here I'm seeing a little further a logarithm of a product right here. So now this product to sum rule will become useful for us. I can rewrite this as same base 10, log base 10 of 10 plus log base 10 of x. And these two are the same these two logarithms are of the same base with this beginning log right here. And so now first term, according to our understanding at this point, log base 10 of 10 equals 1. The next one here is log of x. We have expanded and we have simplified it a little bit. So, and that's what it meant by expand. So we started out from an expression that has a product inside a log, and then now taking the logarithm on a product as an expression right here, we're looking at two separate log terms. We can look at another problem where we can expand a log expression. Let's say now I'm looking at natural log of xy. And so this is just a matter of following exactly the formula. It's a product x times y inside of the log, and here it's log base e, but this property here, this rule, product to sum rule, is for logarithm of any base, any general base. So base e counts too. So natural log of a product x times y equals natural log of x plus natural log of y. And this is about all we can do. But at least this is the expanded form from the beginning problem. Let's look into another problem in our example currently. There will be times where we're taking logarithm of an expression being a product of more than two factors. So how about 5 times a times b? So now we have 3 factors. So now we can expand this product, because what I see here is a product of 3 factors, 5 and a and b. So now with the product to sum, we can further split this or further expand this into log base 10 of 5 plus log base 10 of a plus log base 10 of b. And this is the furthest we can expand.